Hello everyone. Today we are going to move chapter 8 control statements. I am dividing this chapter into two parts and today we are going to discuss the first part. All the C programs that we have discussed so far, the instructions were executed in the same order which they appeared within the program. Each instruction was executed once and only once. Those programs were very simple. But in the realistic programming, we have to include logical control structures to determine if certain conditions are true or false, or to repeat execution of groups of statements, or to execute individual groups of statements on a selective basis, and so on. All of these operations can be carried out using the various control statements in C. In these couple of lectures, we will talk about how those works. If you can remember, in the third lecture, the part 2 of fundamentals of algorithms, I have discussed about control structures clearly and descriptively. And this is an extension of that lecture, how to use those with the C language. Before moving to the main part of the lesson, I am going to recall in some theories that we have discussed earlier, which that we want to apply in conjunction with the control statements. Understanding these concepts is essential in order to proceed in further. In control statements, we need to form logical expressions that are either true or false. To do so, we can use the four relational operators: less than or equal, greater than or equal, and the two equality operators, equal and not equal. You can see some examples for logical expressions in the slide. The first three expressions are involving numerical operands. You can see count less than or equal 100. It means if the count variable is less than or equal 100, it proceeds as true, otherwise false. Second one, SQRT. SQRT we are using for get the square root. So we have to calculate the square root of a plus b plus c. If it is greater than 0.005, this expression proceeds as true, otherwise false. The third one, answer must be equal to 0. It checks the answer variable value with the 0. If that is equal, proceeds as true, otherwise false. Then the fourth example, ch1 less than t. Here ch1 is assumed to be a character type variable. If the character represented by ch1 comes before t in the character set, it proceeds as true, otherwise false. That means if the numerical value used to encode the character is less than the numerical value used to encode the letter t, it proceeds true, otherwise false. The last expression make use of the character type variable letter. If the character represented by letter variable is not x, it proceeds as true. If it is x, then proceeds as false. Then in addition to the relational and equality operators, C contain two logical connectives, or otherwise we can say logical operators and an or, and the unary negation operator. The logical connectives are used to combine logical expressions, so it is forming more complex expressions, and the negation operator is used to reverse the meaning of the logical expressions, that true or false. Here in the slide you can see some examples of logical expressions that illustrate the use of the logical connectives and the negation operator. The first one is count is less than or equal to 100 and ch1 not equal to asterisk. Here count is assumed to be a numeric variable and ch1 is assumed to be a character type variable. In here, if both conditions are true only, this proceeds as true, otherwise it gives the false. It means count must be less than or equal to 100 and ch variable must not be equal to the character asterisk. Then only it gives true, otherwise false. Then the second one is balance is less than 1000 or status is equal to R. Here balance is assumed to be a numeric variable and status to be a character type variable. Here O operator. This proceeds as true if one of the condition or both conditions is true. If both conditions are false, only this proceeds as false. It means if the balance is greater than or equal to 1000 and status variable is not equal to the R, if it is any other character, this complex expression proceeds as false. All other any cases, it proceeds as true. Then the third one, answer is less than 0 or answer is greater than 5 and answer is less than or equal to 10. Here answer is a numerical type variable. Normally expressions are evaluated to left to right. So first we have to check answer is less than 0. Then or answer is greater than 5 and answer is less than or equal to 10. By evaluating one by one, getting the outcome from left to right, we can get the final logical answer as true or false in here. Finally, the fourth one. There is a negation operator in the front. Then within the parenthesis, pay is greater than or equal to 1000 and status is equal to S. In here, pay is a numerical type variable and status is a character type variable. According to the order of the precedence, first we have to evaluate the inside of the parenthesis. If pay is greater than or equal to 1000 and status is equal to S, then the answer will be true. But there is a negation operator in the front, so the expression proceeds as false finally. So any other cases, it will be true. Remember, first to proceed inside of the parenthesis and get the negation. And there is an important point, not the fourth example, look at other three. I have given parentheses to all expressions that combining by logical connectives, but we no need to give any parentheses. We can write those all without parentheses. It will give the same outcome. Why is that? Because the relational and equality operators have higher precedence than the logical operators. So relational and equality operators proceeds first, then only logical operator proceeds. And in the last one, it can also write without parentheses. We can remove inside parenthesis, not the outer parenthesis, because finally at the last we are going to get the negation. There are three different kinds of statements in C: expression statements, compound statements and control statements. An expression statement consists of an expression followed by a semicolon. A compound statement consists of a sequence of two or more consecutive statements enclosed in curly braces. The enclosed statements can be expression statements, other compound statements or control statements. Most control statements contain expression statements or compound statements, including embedded compound statements. So those are the main theories that you want to recall from the previous lessons for this section. Now we will move to the main part. There are mainly two types of control statements. One is branching and one is looping. In today's section, in this chapter, we are going to look about branching. Next section, we will see about looping. So, branching. A realistic C program may require that a logical test to be carried out at some particular point within the program. One of the several possible actions will then be carried out depending on the outcome of the logical test. It means if the logical test is true, a statement or some statements must be carried out. If that is false, some of other statements must be carried out. This is known as branching. There is also a special kind of branching called selection, in which one group of statements is selected from several available groups. In the fundamentals of algorithms lecture part 2, we have discussed some concepts about branching as selection structure. Here we are going to discuss how selection, or we can say branching, applying into the C programming. The first branching option is if-else statement. The if-else statement is used to carry out a logical test and then take one of two possible actions depending on the outcome of the test, that is whether the outcome is true or false. The else part of the if-else statement is optional, so in its simplest general form the statement can be written as if expression then statement. In here the expression must be placed in parentheses as shown in the previous slide. The statement will be executed only if the expression has non-zero value. That means if the expression is true, the statement will be executed. If the expression has a value of 0, that means if the expression is false, then the statement will be ignored. The statement can be either simple or compound. If the statement is compound, it should be enclosed by curly braces. In here you can see the graphical representation of if statement. When a if statement appears in the middle of a program, if the expression is true, the statements will be evaluated and move to the rest of the code. Otherwise, it is directly moving to the rest of the code. Nothing is doing when it gives false. Now we will see some examples for if statements. The first example, if x is less than 0, then printf statement. This is for printing the value of the floating point variable x if that x value is negative. In here, the if keyword, expression and statement all are written in the same line. This works properly. Then the second one, if past due is greater than 0, credit equals 0. If the past due is greater than 0, the value 0 is assigned to the credit. In here, if keyword and expression in one line and statement is in the second line. This also works properly. Earlier also I told you that the indentation is only for enhance the readability. It is not doing any other effect to the code. Then the third one, it is containing a compound statement. That's why we are using curly braces in there. If we giving only one statement under any control statement, we no need to give curly braces. If you want, you can give curly braces to that also, it doesn't matter. But remember, if we are giving more than one statement to evaluate under a control structure, we have to enclose them by a curly braces. Otherwise, it will evaluate the very first statement only. Others will be ignored. So in here, the compound statement will be executed. The floating point variable y is evaluated and then displayed if x value doesn't exceed 3. Otherwise, the statements will not be executed and they will be ignored. In the fourth example, you can see complex logical expression as single statement. The floating point value of the balance variable will be displayed if its value is less than 1000 or if the status has been assigned to the character R. If both conditions are false, only this statement won't execute. And in here I have used parentheses inside of the expression also to give you improve the readability. If you want, you can remove the inner parentheses. Then the last example, that I have both a complex logical expression and a compound statement. In here, if the current value of A is non-negative and the current value of B does not exceed 5, then the variables x min and y min will both be assigned appropriate value. If both conditions in compound expression are true, only the statements are executing, otherwise ignoring the structure. Okay, now you have an idea how to use if statements. As I said earlier, if statement can be followed by an else clause. Earlier the statements are executed only the expression was true. But in here, by use of else clause, we can give some other statements to execute if the expression is false. You can see the general form of an if statement which include the else clause in the slide. If expression statement 1 is statement 2. If the expression has a non-zero value, that is if expression is true, then statement 1 will be executed. Otherwise, if expression is false, then statement 2 will be executed. Then in here you can see the graphical representation of if-else statement. When if-else statement appears in the middle of a program, if the expression is true, it evaluates the statements under the if condition as statement 1 in the flowchart. And if that is false, then the statements that under the else condition as statement 2 will be evaluated. And in both conditions, after going through the if-else structure according to the true or false, it will move to the rest of the code. Now we will see some examples for if-else statements. First, a simple example. The value of tax is determined in one of two possible ways depending on the character that has been assigned to the variable status. If the status is S, then tax equal 0.20 multiplied by pay. If the status variable is any other character, it will be calculated as tax equal 0.14 multiplied by pay. Then the second one, it examines the positive status of an account. If the value of positive exceeds 0, a message is displayed and credit limit is set to 0. Otherwise, credit limit is set at 1000. Earlier, first example, we didn't use curly braces because each if and else clauses having only one statement under them. But in here, for the if part, we have using curly braces due that we have two statements to execute. But in the else part, only one statement. Then no need of curly braces. Now look at the third example. The value of y is computed differently according to the x value. If x is less than or equal to 3, then y equal 3 multiplied by power x comma 2. Here power is POW is the function for calculate the power that includes in the math.h library. And if x is less than 3, y is calculated as y equal 2 multiplied by power of x minus 3 to 2. Now seen here, there are no curly braces. The if part is okay because there is only one statement, but in else part there is two statements. Why I am not using curly braces? Because I want only to calculate y instead of the if and else statement. After that, whatever the y value, I want to print it. Instead of writing two printf statements to the if and else separately, I used one printf statement in the outside of the if else statement. So that's why I didn't use curly braces in here. The fourth example shows how an area can be calculated for either of two different geometric figures. In here, the specialty is the logical expression I have given as a label, circle only. So, if circle is assigned a non-zero value, it means true. The radius of a circle is read into the computer, the area is calculated and then displayed. If the value of circle is 0, if it is false, then the length and width of the rectangle and are read into the computer, the area is calculated and then displayed. In each case, the type of geometric figure is included in the label that accompanies the value of the area. Okay, now you have an idea about how to use if-else statements in C programming. It is possible to nest, or we can say embed if-else statements one statement within another. There are several different forms of nested if-else statements can take. In the slide, you can see the most general form of two-layer nesting. If expression, then inside of if statement, again if-else statement, and the else part also containing another if-else statement inside of that. If expression 1 is satisfied, then the inner if-else can consider. If that is false, then the else part if-else can consider. And in here, the places statement 1, statement 2, statement 3 and statement 4 can contain other if-else statements. We can replace those with other new if-else parts. So then it would be multi-layer nesting. In here you can see some other forms of two-layer nesting. The first one is if expression 1 statement 1 else if expression 2 statement 2. For the if condition, one statement will be evaluated. If it is false, then another if statement will be evaluated. There is no else part for the last if statement. Then the second one is if expression 1 statement 1 else if expression 2 statement 2 else statement 3. In here, for the if condition, again one statement will be evaluated. For else part, another if else statement will be evaluated. In the third one, if expression 1, if expression 2, statement 1, else statement 2, again else statement 3. In here, the if condition contains another if else structure and else part only contains one statement. In the last case, if expression 1, if expression 2, statement 1, else statement 2. Here, however, it is not clear which expressions that expression 1 or expression 2 is associated with the else clause. The answer is expression 2. The rule is that the else clause is always associated with the closest preceding unmatched if. It means the last elseless if. This is suggested by the indentation. Through the indentation itself, it is not deciding factor. If we use curly braces after if expression 1 and after statement 2, it gives us the same as without curly braces. If we use braces out of the if expression 1 statement 1, then the else part belongs to the first if. The inside of if condition not having a else part. So do the nesting carefully, otherwise it will give different outcome other than you think. Now we will see nest multiple if-else statements. We can say this as if, else, if. If, else, if statements are used to execute statements based on multiple conditions. This forms a ladder. In the slide you can see the general form of if, else, if statements. If expression 1, then statement 2, 1, else if expression 2, then statement 2, else if expression 3, then statement 3, else statement 4. If the expression 1 generates a non-zero value, it means true, the statement 1 will be executed. If the expression 1 generates 0, it means false, then the expression 2 will be evaluated next, and if it is true, statement 2 will be executed. This process will be carried out for all the else if condition until a true condition found. Finally, if neither condition is true, the statement in the else block will be executed. It can be used to provide a default condition or an error message. So, when a logical expression is encountered whose value is true, the corresponding statement will be executed and the remainder of the nested if-else statements will be bypassed. So, the control will be transferred out of the entire nest once a true condition is encountered. Now in here you can see the graphical representation of the if-else if statement. When this appears in the middle of a program, if the expression 1 is true, then statement 1 will be executed. If not, it will be checked for the expression 2. If it is true, then statement 2 will be executed. Otherwise, again move to the next if condition. Finally, none of if condition is evaluated to be true, then the else part statement will be executed. After that, the rest of the code will be executed. Now we will see an example for if, else, if statements. In here, the different values will be displayed according to the various numbers. If the variable a is equal to 10, then it will be displayed value of a is 10. Else, if a value of a is 20, then it will be print value of a is 20. Else, again if is equal to 30, it will print value of a is 30. And if the value of a is other than 10, 20 or 30, it will display an error message that none of the values is matching. Okay, now you got an idea how to use nested if-else statements. Then the switch statement. The switch statement is used to select a group of statements from a few available groups of statements. This selection happens based on a current value of an expression which is included within the switch statement. The general form of a switch statement can be written as switch, then expression and statement, where expression resides in the integer value. And note that expression can have also the character type, since individual characters have equivalent integer values. And the embedded statement is generally a compound statement that specifies alternate course action. Each alternative is expressed as a group of one or more individual statements within the overall embedded statement. For each alternative, the first statement within the group must be preceded by one or more case labels. So otherwise we can say case prefixes. The case labels identify the different groups of statements, it means different alternatives, and distinguish them from one another. The case labels must therefore be unique within a given switch statement. So each group of statements is written as case expression, statement 1, statement 2 up to statement n. Or when multiple case labels is required, then case expression 1, case expression 2 up to case expression m, and statement 1, statement 2 up to statement n. In here, expression 1, expression 2 up to expression m represent constants, integer value expressions. It means integer constant or a character constant. Each individual statement following the case labels may be either simple or complex. So the switch structure can be written as switch expression, then inside of the curly braces case label 1, statement 1 break, case label 2, statement 2 break, and up to case label n, statement n break. Each group is defined and identified by a case label, and each case label is constant integer valued expression, as I told earlier. Case labels are unique within a switch statement. When the switch statement is executed, the expression is evaluated and control is transferred directly to the group of the statements whose case label value matches the value of the expression. If none of the case label values match the value of the expression, then none of the groups within the switch statement will be selected. In this case, control is transferred directly to the statement that follows the switch statement. It means switch statement will be ignored. The break statement signals the end of the particular case and causes execution of the switch statement to be terminated. You must remember to include the break statement at end of every case. Forgetting to do so for a particular case will cause program execution to continue into the next case whenever the case gets executed. Now see the example in the slide which illustrates a simple switch statement. In here switch, then the expression and the cases that have to be satisfied within the curly braces. Here choice is assumed to be a character type variable because we are getting a character type variable from getShare. So red will be displayed if choice represent either simple R or capital R, and white will be displayed if choice represent either simple W or capital W, and at last blue will be displayed if choice represent simple B or capital B. Nothing will be displayed if any other character has been assigned to the choice. And in here I have used two case labels for account for the uppercase and lowercase. You can see both simple and capital, it will be displayed the statement. So the break is used to prevent of the execution of more than one group of statements. One of the labeled groups of statements within the switch statement may be labeled as default. If none of the case labels match the value of the expression, the statements group labeled with default will be executed. The default group may appear anywhere within the switch statement. It no need to necessarily placed in the end of the switch statement. This is commonly used to generate error messages or error correction routines. If the default group is not present and the expression value does not match with any case label, no action will be taken. So in here you can see an example for switch statement with default clause. Each of the first three groups of statements now has only one case label. Multiple case labels are not necessary in this example because the library function to upper I have used in the switch expression. It converts all incoming characters to be uppercase. Hence, the choice will always be assigned an uppercase character. And I have given the default case in here. If none of the case is matched, it will go to the default case and it will print error. Now in here you can see the graphical representation of the switch case statement. When this switch case appears in the middle of a program, if the case label A is true, then case A action will be taken and break, or otherwise if it is false, then it will consider the case label B, and if it is true, then case B action will be taken and break. This is go up to the when one condition is true, otherwise it will go to the until the case N, and if it is true, it will take the case N action and break. If all the cases are false, then it will go to the default case. After that, the rest of the code will be executed. Okay, now you have got an idea about the switch statement also. From this lecture, I think you have got an idea how to use selection structures in the C programming. If else, nested if else, and switch. I will discuss the loop-in structures in the next part of this chapter from next lecture. I have uploaded the PDF version of these slides and a simple worksheet for this part. Find these and try to write the answers for worksheet. And also use the reference books, and you can go through the third lecture, the part 2 of the fundamentals of algorithms, again for more explanations. If you have any doubts or any other thing that you cannot understand and you want to know, you can contact me through the email. I have given my email address as usual in the first slide. Thank you.